Addressing water issues in cosmetics. This presentation is divided into 3 parts. I'll be talking about chemistry, Sebastian will be talking on physics, and Sandra on geospatial science. So, in Australia, a cosmetic product is defined as a substance or preparation intended for placement in contact with any part of the human body. To ensure that there's no significant harm to users and to the environment, safety testing and regulations are carried out. During safety testing, there's 3 methods: in silico, in chemical, and in vitro. For in silico method, they use computational method to analyze or simulate or visualize the toxicity of chemicals, and in chemical uses knowledge of chemical reactivity to provide information related to toxicity, and in vitro method uses reconstructed human epidermis models to test for skin irritation or sensitive skin, eye irritation or phototoxicity or acute toxicity. And the regulation and safety is carried out by the NIC/NAS. So what they do is they scientifically assess and approve each and every single ingredient in the cosmetic product. And if appropriate, they will also restrict the concentration of the chemical that's being used. Next, there is high water consumption throughout all stages of a cosmetic product's life cycle. During the formulation design of a product, water is a primary component in almost every type of cosmetic product. During sourcing of the ingredients, water is used to manufacturing, packaging of products, distribution, and consumer and post-consumer use. All of this can lead to wastewater pollutants. The more common pollutants are sulfites and ammonia. They can potentially increase pH. And there's also phosphates and polyphosphates. They promote eutrophication at high concentrations. Parabens, they are commonly used as preservatives. They are toxic to aquatic organisms. And there's also residues from rinse-off products like surfactants, dyes, fragrances, microplastics from your exfoliations, sunscreens, and they are toxic to microorganisms and they can bioaccumulate in aquatic ecosystems. To treat this wastewater, there's different technologies. There's physical technologies, there's biological, and there's also chemical technologies that's being applied to this. Another way to address the water issue is to use this approach of waterless life cycle to reduce the water footprint. This can include developing waterless fast rinse-off or non-rinse-off formulas, and sourcing sustainable raw materials, finding alternative water sources, and also optimizing manufacturing processes. And they can do this by trying to include the adoption of circular water management in their facilities, and also using biodegradable, recyclable, and reusable packaging, as well as improving transport infrastructure. Lastly, what we can do as consumers is to responsibly use and dispose of products.
Okay, so thanks Abby for that detailed talk about chemistry, and hello everyone. I'm Sebastian and I'll be covering the physics in water-based cosmetics. So just to introduce you to the topic, let me outline current issues that scientists are trying to solve. Well, scientists and brands alike are wanting to create high quality products with a long life without producing too much waste. But in order to solve these issues, it's important for us to understand emotions, which are the foundation of many water-based cosmetic products. So, as seen in the diagram to the left, emulsions can be defined as liquid-liquid combinations, like your water and your oil, that don't naturally blend together without physical intervention. It's because of this that they're considered unstable, meaning they lack the ability to resist physiochemical change. However, the manipulation of four main processes: foaming, creaming, coalescence, and flocculation, scientists can actually adjust the stability of these emulsions. However, failing to do so can cause the product's ingredients to separate, similar to the water and the oil in this GIF right here. So, in the next few slides, I'll go over how physics is currently being applied to solving and creating stable emotions. So, the application of physics in cosmetics at a fundamental standpoint can be based off the properties of viscosity and laminar flow. So, as seen in the diagram, laminar flow can be defined as a fluid's particles moving in layers parallel to each other without mixing. So, all those green lines right there moving in the same direction but not mixing together. And viscosity is the friction between the molecules of a fluid or the friction between each layer in the system. This is important to understand because products made too viscous or too thick can be hard to apply and be absorbed, whereas products made with little viscosity can be hard to get an equal spread and coverage on the skin. So, continuing on with the application of physics in cosmetics, here's some current research and evidence scientists have made. At one, we have formulation. So, one study shows that emulsion composition, which is the ingredients in your product, heavily dictates the stability. One way that they found helped stabilize the products was the incorporation of electrolytes. They also tell us that lipids and oils are necessary for liquid crystalline structures. These liquid crystalline structures increase the viscosity of the system and overall helping keeping it stable. At two, we have shear mixing. Shear is defined by the stress that is applied to a liquid or fluid by a mixing blade or an impeller. So, in their experimental study, they found that shear mixing at 4000 RPM for 3 minutes was optimal for making emulsions. As scientists, we can gather that the shear mixing rate and the shear mixing time is important to consider when creating quality and stable products. And third, I have Pickering emulsions. Pickering emulsions are emulsions made with specifically stabilized particles. These stabilized particles contribute to eliminating the toxicity and the irritation that can be caused from other types of cosmetic products. Alright, so now that we understand that scientists have the ability to create stable emulsions, to address the issues aforementioned, they must formulate and also use the correct mixing techniques in order for these products to be put to market use. Specific examples of these solutions could be additive compounds, like your electrolytes from earlier, which can help produce the desired rheological consistency in water-based cosmetics. The use of physical barriers like packaging also contribute to preservation. This is because they stop the product from interacting with things from the outside elements, which could potentially change the physiochemical structure, thus making it unstable or risking infection or spoilage. However, some outstanding challenges are yet to be dealt with. This comes from 100% natural products, which has increased in popularity, and these products don't always have chemical stabilizers. So, since these products aren't guaranteed to stay stable, a solution to this could be refrigerated supply chain logistics, or your refrigerated trucks. This will help with controlling the consistency and the product life of the emulsion until they reach the user. So, this was physics in water-based cosmetics. Next, I'll hand it over to Sandra, who will talk about geospatial science.
Geospatial. What is it? Geospatial science is a form of research utilizing satellite technology, remote sensing technology, and data to analyze and showcase the geographical landscapes of the Earth. Additionally, this data can further be used to observe the change in the land over time, predict weather patterns, and measure the concentration of gases in an area, among other things. All this data can be slotted into the Geographic Information System, the GIS, to allow further assessment and breakdown of data to help pinpoint and analyze locations of choice. Mapping out drains and deducing water quality. Geospatial science utilizes remote sensing technology to map out the geographical landscapes and sources of water in real time. With the help of remote sensing technology, it also helps to pinpoint direct sources of water being used through visual imagery. Paired with real-time analysis, it helps to determine the quality of water at any given point in time. How does this relate to cosmetics? Water is one of the many ingredients used in the process of making cosmetics. To use it, however, manufacturers must ensure that the water quality is safe enough to be used in their product, much less it ruins the batch of cosmetics it is used in. One of the ways that quality checks of water can be conducted is through real-time monitoring of the water supply. This will allow for workers to understand if water from a source has been contaminated or unsafe to use. By receiving data in real time, if the water is contaminated, it will allow workers to act quickly to stop further contamination and helps to optimize treatment processes, ensuring the water quality is safe for further cosmetic use. Weather forecasting. Weather forecasting is one of the more prevalent uses of geospatial technology and falls under the responsibility of the Australian Bureau of Meteorology. One of the ways that geospatial science is used to predict weather is by timing the delay in receiving signals from satellites due to the moisture in the troposphere. Another way geospatial techniques can be used to predict weather patterns is by mapping wind and wind strength. This helps to predict where rainfall is likely to head and how long the rain will last. Applications of weather forecasting in cosmetics. Although this may seem like a small problem regarding cosmetics, forecasting the weather is crucial to farmers in making sure their crops are able to grow. Cosmetics require plant resources as well, these resources often being sourced from said farms. This lets farmers know when rainfall is expected, allowing them to adapt the plants so they are able to grow in spite of weather conditions. The Australian Bureau of Meteorology further uses remote sensing technology to aid farmers by showcasing forecasts for temperature, frost, humidity, and so on to help farmers prepare weather that may end up affecting crops. The quality of these crops may have an overarching effect on cosmetic products, either ruining it or improving it. Furthermore, manufacturers may limit production of cosmetics should the product be ruined by poor quality material. Overall, science plays a crucial role in addressing water issues in cosmetics by providing solutions to help reduce water consumption, test the stability and safety of the product, and enhance product quality, ensuring that all of it is safe to use. These are references for chemistry, these are references for physics, and these are references for geospatial.